because you have to do way more on this one than you do on any of those, on the one that you actually have. Is it still frozen? Yeah. It is still frozen. It is still frozen. There we go. So on this one, let's just take a look at what it says first. It says a $200,000 loan is repaid over 20 years in an equal monthly installments. What's the key word right there? Yeah, monthly and equal. It's two words that are here. Equal monthly installments of M dollars beginning at the end of the first month. Find the monthly payment if the loan is at an annual interest rate of 9% compounded monthly. Compounded monthly. So if you borrow money now, money over time, what happens to money over time? It increases, because if you borrow money, you don't just pay back the same amount in 10 years. You're going to pay back more than that. Does this make sense, everybody? So we need to generate a geometric series to add together here. We need to generate a geometric series to add together. Are you with me so far? There are 240 payments going into it. Do you agree? They are all the same size. Do you agree with that? They're all the same size? This is very much a real world question because car payments are the same every month. Your mortgage will be the same amount every month. It doesn't change. It doesn't change. But here's the thing. This is $200,000 now. $200,000 right now. So what do we have to set? Seen that before? Yeah, usually it's the P equal, the P. So this represents the present value. Present value. Now, are all of these payments in play for the same amount of time? No. No, they're all made at different times. All these payments are made at different times. They're made at different times. What happens? You're done, right? So this account is growing, but you're chipping away at it, right? And then that last payment, what does it do? It hits zero, right? Okay, so the idea is this whole question revolves around the idea of present value. Present value. So first of all, you have to be really careful. What's the R value in this case that we're dealing with? What's the R value? 0.09 is the yearly interest rate, but you're compounding it monthly. You have to be very careful. So what's the R value going to be? 0.09 over what? 12. And that's equal to 0.0075. Are you okay with so far? So that's the interest rate you're dealing with, okay? So if we were to plug these values in right now, we have M is equal to P times 1 plus 0.0075 to the T. I'm going to do these piece by piece because they're slightly different for each piece. What you're doing is you know that $200,000 is the present value of the loan. Do you agree? That's the present value, meaning how much it is worth right now. And you're breaking that apart into how many different payments? 240 payments. So there's one payment, two payments, three payments. How many of them are there? There's 240 payments. 240 of them. 240 payments. And each of these is the present value of the present value. We're adding all the present values up. Does this make sense, everybody? Because what is 200,000? 200,000 is what type of value? What is it? It's a present value. Present value. So we want to add up the present value of each of the payments. And when you add up all the present values of the individual payments, it should add up to what? $200,000. Are you with me so far? Yeah. 200,000 is the present. We're looking at it from right now. Okay, so the idea is this. So if we look at the first payment, let's look at the first payment. So the first payment is going to be M. Does everybody agree? It's the same value. It's the same one, right? The present value of the first payment is going to be 1 plus 0.0075. So what is that? It's 1.0075 raised to the what power? If it's the first, because it's at the end of the month. It's at the end of the first month. We're not paying at the beginning, at the end of the month. So what does P1 equal, Wiley?
I don't have that.
Simplify that algebraic expression for me right there. M equals P1 times 1.0075 to the first. So what does P1 equal?
M divided by
yes.
1.0075
to the first. So that right there is the present value of the first payment. Do you agree with that? That's how much the first payment is worth right now. Does that make sense, everybody? Mm-hmm. It should kind of make sense because look, if you want to have $10 in your bank account at the end of the month, do you put in more or less than $10 at the beginning of the month? Less, because it needs to what? It needs to grow into it. So what this says is, let's say we know what the monthly payment is. The present value is that divided by 1.075 because it has to grow into that first present value. Does that make, it has to grow into M. Does that make sense, everybody? Does it kind of make sense-ish, right? So when you pay $10 at the end of the month, it's really worth how much now? Like 9 point, a little bit less. Whatever it depends on the interest rate, right? But that 9.8 is now money. $10 is the end of the month money. Are you with me so far? We're adding up present values. The way these can get messed up, and what I screwed up last class on this was I was mixing money in the future with money now. What happens when you do that? Bad things. Can you mix the two? No, you really shouldn't. So let's watch the pattern. One sec, team. Let's just, one sec, okay? Let's watch the pattern. So P1, what was P1? There's 240. P1 was M over what? 1.0075 to the first. What's the next one going to be? M over 75 to the second. And it's going to go all the way up to, what's the last one going to be? M over 0.075 to the 240. Just raise your hand. Are you with me so far? Are you with me so far? Raise your hand if you're like at least kind of with me right now. If you're kind of with me. So the idea is this. How about having this geometric series? Once we had the geometric series, is it really, really, hopefully straightforward? What? Yeah. Hopefully, right? So what geometric series do we have here? We have this one right here. M over 1.0075 to the first plus M over 1.0075 squared all the way up to what? M over 1.0075 to the 240th is equal to 200,000. And I put that in the wrong spot. Is this okay right here? Are we okay? So the real question is, what kind of series is this? What is that? It's a finite geometric series. It is a finite geometric series. Can you tell me what's the A value? What's the starting value? What's the first one? Careful, what's the first value? What's the first listed term? M over 1.0075. What's the R value?
1 over.
Yes, what'd you say?
1 over.
Yes.
Or is 1.075 and a negative 4?
Either way is fine. Yes, absolutely. But are you okay with those two things? How many terms are there? Hey, at least this one starts at 1, right? Sometimes they start at 0 and it tricks you up. Number of terms is 240. So if we want this sum, how do you figure out what the sum is? It's A times, so M over 1.0075 times what?
1 minus 1 over 1.075
To the
240.
To the 240. All over what?
1 minus 1 over 1.075.
Exactly. What do we think of this so far? What do we think? The M is right there. So this is this times what? M. But that is equal to what? 200,000. So then you get M is equal to, I think, like 1,799 something?
Yeah.
What is it?
1,799.452.
452? Excellent, right there. Yeah, so Nam wanted to know about this one. It's asking it asks whether it converges or diverges, right? I think. What type of series is this? Yeah, alternating. You can say alternating and it automatically implies negative, positive, negative, positive, negative, positive. What's the limit as n goes to infinity of the absolute value of this thing? What's the limit of the terms, of the absolute value of the terms?
1 over n to the half.
Yeah, so what is that as n goes to infinity?
0.
0. So this is an alternating series that goes to 0. So it's an alternating series that goes to 0. And also, is it monotonic? Does it just decrease towards, does the absolute value just decrease? It does. So therefore, what do you know this does? It converges. That was one of the tests, everybody. If it's alternating, if it's alternating and goes to 0, it converges.
Oh, I thought you were up.
If it no, look, this gets big, right?
Yep.
But that's on the bottom.
I messed that up.
Yeah, if this was next to it, it'd be like, yeah, it gets big.
Yeah.
But this gets small, but it's only because it's alternating and it's going to 0 monotonically. Does that make sense, everybody? Yes?
Does an always have to be smaller than
Yes.
an plus 1?
Correct. The absolute, for this, yes. For the alternating, the absolute value does, yes.
Do you have to prove it?
No, you can just say, this gets bigger monotonically, so 1 over gets smaller monotonically.
Okay.
You don't have to prove it. This would be okay right here. You could say this is alternating and it goes to 0, therefore converges. This is fine.
Okay.
Totally fine.
But you could also do the thing where you do.
Complete. You could just say it's monotonic, which that means the absolute value of an plus 1 is, what is that related in this case? It has to be like that. You could say that too. That's fine. It has to do that. At least at a certain point it does, forever. It can go crazy for a while and then calm down, and then it still is going to converge. Does this one make sense right here? We good? Yeah. So what's the easiest way to show this one does or doesn't converge? You could try limit comparison test, right? You could try limit comparison test. So it either needs to be less, you could be less than, there's comparison and limit comparison. Which one do you want to do?
Comparison is the easiest.
Comparison is theoretically the easiest. So you either need, for comparison, you want it to be less than something that converges or greater than something that diverges, right? Greater than something that diverges. What about this one right here? What happens to this one?
Bigger than the harmonic.
Is it bigger than the harmonic?
It's smaller.
Does that help us?
No.
No. So at first you're like, yay, it's smaller than something that blows up. Does that help us?
No.
Because this denominator is bigger. This denominator is bigger. So you can't just use the comparison test. It doesn't quite work on this one. So which one do you want to try next? The limit comparison. So what's the limit comparison? What do you want to compare it to?
1 over n.
So you want to compare it to 1 over n, right? Does it matter which one you put on top or bottom? Remember how it's an over bn? Does it matter which one you do?
No.
It doesn't, because look, you're just trying to find that the limit is greater than 0, right? If c is greater than 0, what else is greater than 0? 1 over c, right? And if 1 over c is greater than 0, then c is greater than 0, right? Is everybody with me so far? It doesn't matter. You could choose it based on what looks prettier, I guess. So what limit are you're going to do it with this one? Because you know that this what? What does this do? Diverges, right? So what limit? Can someone tell me the limit I need to evaluate? Limit as what goes to what? N goes to infinity. Which one do you want on top?
1 over n plus 1.
Sure. 1 over n plus 1 is the one I heard loudest over this. So what's that? The limit as n goes to infinity of n over n plus 1. And what does that equal? Greater than 0, therefore must also, and what I would do is this. This is how I would label it. I would just call this whole thing bn, like that, and this one an. Therefore, bn must also do what?
I thought the relationship with 0 didn't matter, just the fact that it came to an integer.
It has to be greater than 0, I think, on this one, right? The limit comparison. For limit comparison, it needs to converge to something greater than 0, right? Yeah. Right, so it has to be, it's great, that's what this means right here. It's greater than 0 right there. Therefore, bn must also what? Diverge. Like an. Does that make sense? So it looks like you could do the comparison test, but can you? No, because less than diverge does not tell you anything. Greater than converge doesn't tell you anything. Be very careful. Can guarantee you're going to have comparison and limit comparison questions on the test. Absolutely. And for the most part, I'll give you a hint, most of the questions, they're going to tell you which test to use. Sound good? You're welcome. Thank you, Mr. Seamon. Okay, so for this one right here, it's just, I think, is it just asking converge or diverge? Yeah. Does it say what test to use? Yeah, it just says, does it converge or diverge, right? What's the first thing you always have to test to see if a series converges or diverges? What's the first thing you always test? Does the limit equals 1 to sorry, I'm mixing summation and limits. Great. As n goes to infinity, you want to test this. Does it has to what? If it goes to 0, then it could converge, right? Why do you test this? Because if it doesn't go to 0, then what? It definitely diverges, right? The thing about this is, what about this one? What does this do? Yeah, this thing right here lives between what and what? -1 and +1, right? It could be equal to it, right? So what could it be? It could be at greatest, what? 1 over 2 minus 1, and at least what? 1 over 2 plus 1. 1 over 2 plus sine n is either less than or equal to 1 or greater than or equal to what? 1/3. So therefore, what happens? It does not go to 0. So therefore, what does it mean? So the sequence of the terms don't go to 0, so it must diverge. You always check to see if it goes to 0, because if it doesn't, you're done. If you have a series and the sequence of the terms doesn't go to 0, you're done because it diverges. Yes?
So is it possible to like a sine or cosine on the bottom